In this video, we're going to start talking about the SUMA functionality within AFNI. So I'm going to open up a terminal, and I'm going to go to the AFNI handouts directory. And if I look at the SUMA files that are here, actually we can open up two of these immediately. I'm going to open up the SUMA PDF and SUMA keystrokes. So I can type AFNI open suma.pdf, and you should see a handout like that. And when we come to using SUMA, the GUI itself, to look at surface data, we can have this kind of cheat sheet open up. So I'm going to open this now in a text editor. Again, you can use any program you want on your computer. I'm just going to make sure that this is a command that should work on any system. And I'm going to put aside this text file for the moment, and let's just start going through the PDF here. Okay, so everything that we've looked at earlier on, if you've been following most of the other videos in this academy, has been looking at data in the AFNI GUI, and we think of the brain as being looked at slice by slice, and our individual unit here is voxels. Okay, and so these are our three spatial dimensions of slices in each of the major viewing planes, and then we can also have another axis of time. However, the brain isn't organized slice-wise like loaves of bread. Instead, we have sulci and gyri that move around through all these slices, and so sometimes it would be nice to have some kind of rendering where we could look at these surfaces, like the whole cortical sheet or the cerebellum or something like that. So a surface embedded in 3 dimensions that isn't just like a flat piece of paper or something. And this is the realm of SUMA. So these are both the same data sets being looked at in different ways. Here in slice-wise, kind of what we'll call the AFNI way of looking at things. And here, when we think about a surface, and we'll talk about meshes, that's in the SUMA realm of things. And if you notice here, thinking of data volumetrically and on a surface are as complementary as the sun and the moon. There you go. So SUMA stands for surface mapping, and originally this was developed slightly separate from AFNI, but now it's just a part of AFNI. And when we refer to the SUMA functionality, again, we'll be typically talking about things that are embedded surfaces, one-dimensional tracts in 3-dimensional space, or 2-dimensional surfaces. And the nice thing is that, again, there's complementary functionality. Sometimes you want to look at data one way, sometimes you want to look at it another way. And when we mostly refer to AFNI functionality, we'll talk about volumetric data sets, NIFTI, brickhead format type things. And SUMA, we'll talk about surfaces, GIFTI data sets, NIML-D sets, and some other things like that. A lot of the same kind of functionality and development style from the main AFNI programs also applies to the SUMA programs. And one question is, where do we get the surfaces from, these kind of nice anatomical surfaces that we see? We can generate surfaces in AFNI for really very detailed ones. We leave most of that estimation to other people. So we have programs that will make surfaces of ROIs or things like that. But if you really want to know depth or some things like that, FreeSurfer is a very common software, and we'll see that there's tools in AFNI to bring the outputs of any one of these data sets created by any one of these software into AFNI. And also recently there's been another software for generating surfaces for macaque brains called Civet. And we'll see that similarly, the same things that we'll talk about here with basically FreeSurfer output for humans would also apply there. So there's still kind of growing functionality. Okay, so what do you need to do to be able to use SUMA in kind of the classical sense we'll talk about? There's lots of different things that you can do. Well, basically you just need one good high-resolution anatomical data set. In the old days, this might involve making one or a few T1 weighted volumes that you would acquire, average together for higher SNR. Anymore, really, it's very easy to get good high resolution data sets. And typically here we're talking about 1 millimeter isotropic, T1 weighted standard MP range. Probably want a whole brain data set. Within, for example, some of the software that process and create the meshes, there are some non-uniformity correction tools, N3, or even now I guess what's called N4 normalization, for example, in FreeSurfer. AFNI also has 3D unifies. In general, we're going to talk mostly here about using FreeSurfer output. They do have their own normalization for their anatomical estimation, so you don't even have to do anything before using it. Okay, and then you would, once you acquire it, basically you can kind of skip to this step and plop it into one of your software. And around that, what we're going to do is the software, for example, FreeSurfer, creates a mesh. We want to talk about the same kind of equivalent idea of what we have in volumetric data sets, where we have a standard framework for analyzing our data set. So in the volume, we talk about standard space. On the surfaces, we're going to talk about a standard mesh. And so in AFNI, when we translate surfaces from, let's say, FreeSurfer, we always create standard meshes. So that basically, in the same way that standard template data set, your unit of measure, a voxel, the same IJK or XYZ location, you want to represent the same anatomical location. In the same way, when we have a mesh, we'll want the same node to represent the same anatomical location across subjects. So we'll talk about that. We also have the ability to align the surface to experimental data. There's a program in AFNI called @SUMA Align to Experiment. And very usefully, this gets into the complementarity of AFNI and SUMA. We can map volume data to the surface and also surface data to the volume back and forth. And we'll take a look at this. And in the same way, in AFNI, for every voxel, we can think about storing a single number or a time series of data, like with EPI data. We can do the same thing with SUMA, and a lot of the programs in AFNI, like 3D Calc, 3D TSTAT, 3D Info, will work on the surface data sets in the same way. So any program that does just a voxel-wise calculation for the brick head data sets, or what you would want to do a node-wise calculation on a mesh, so just a individual spatial unit, you do some calculation there. Actually, you can use those same programs on surface data sets. And for any program that involves something like spatial information, now that's going to be different because we're on a mesh, not in a volume. So SUMA has its own programs for things like blurring data, smoothing data, calculating distance along the surface, and some things like that. Okay, so sometimes people just want to take their data that they process in the volume and display it on a surface. And that's fine, nothing wrong with that. Actually, we have some pre-made surface data sets for a lot of the standard spaces, basically for MNI and the Taylor-Act-Turneau. And so these surfaces, basically these data sets were put into FreeSurfer's Recon All program, and then they came out, we translated them into NIFTI and standard meshes and good things like that. And you can download those from the website. Probably there's actually an HTTPS here on each of these web links. That just something to note. Okay, and then we'll discuss projecting volumetric data onto the surface, but you can do that, and sometimes people like these flat maps like this, or other different types of representation. All right, so what do we do to kind of plan to use SUMA? As we noted, you acquire your high-res anatomical MRI data, so something like a 1 millimeter isotropic T1 weighted volume probably takes about 4 minutes or something of scan time nowadays. Then you would take that data set and you put it into your surface model creator of choice. For example, FreeSurfer is a common one. It provides not only surfaces, and actually a family of surface that you can see a little bit here, but also anatomical parcellations of the cortex and a bit of the subcortex. So a couple of useful functionalities. Once you do that, then you take your original anatomical and you take your FreeSurfer output and you just put it into @SUMA makespec. And for each of these estimator programs, there's a program to translate all their output into usable format for AFNI. And by usable, we just mean standard things like NIFTI data sets and for the volumes and GIFTI data sets for the surfaces. And @SUMA makespec does pop out a surface volume, so AFNI format or NIFTI format surface volume aligned with the surface models, and a specification file or a spec file that defines the relationship between different surfaces. So we'll see these kind of family of surfaces, basically a different way of viewing the same set of nodes in space. There's also the parcellation files, both volumetric and surface, and we'll take a look at those. Okay, so again, as I noted, for each of these software, there's a particular program in AFNI to translate their output. FreeSurfer, there's basically a reconable program, fairly stereotyped, kind of single use for default that makes it pretty easy, and the same kind of outputs are presented then, and so it's pretty easy to translate. Again, we noted these are the kind of outputs for FreeSurfer: the anatomical MRI aligned to the surfaces, cortical and subcortical segmentations. There's two different atlas that are estimated. Then the surfaces themselves and the specification file representing how those surfaces relate to each other. Okay, so for viewing surfaces with SUMA, we can go do that now and get a sense of some of the SUMA functionality. So let's do that. Okay, so the demo in your bootcamp, if you have it set up like normal, you can just CD to this directory, AFNI Data 6, FT Analysis, FT SUMA. And again, FT is just the older style of coding for a subject ID. Okay, so now we're in this directory, and if I type ls, we'll see just quickly what's here. There's a lot of data sets here. These are the parcellation segmentation files. The REN, we can talk about, these stand for renumbered. So this just means that to use our color maps in AFNI, we renumber, and also we've grouped some of the outputs by useful tissue types. So CSF, gray matter, ROI, light gray matter, because there's some gray matter that's kind of dotted around, ventricles, white matter, unknown. So that way you get, and there's also all the ROIs in a single volume, but we tried to, they're different, we'll see in different processing, there's different reasons to use different kind of tissue types. All these things that start with STD stand for standard, and there's standard 141 and standard 60. These stand for different sizes of meshes. Okay, so we'll take a look at more of this later. Why don't we just start opening up AFNI and SUMA. So here's AFNI command. Now if you notice, when I run AFNI, this time I'm adding an argument minus NIML. NIML stands for Neuroimaging Markup Language, and we'll see why that's useful for some complementary functionality between AFNI and SUMA. So I just copy and paste that there. AFNI opens. And to run SUMA, there's a script that we're actually going to run here. T-shell runs SUMA. If I just quickly list the script, there's some different scripts here, and we'll take a look at a couple. But we're just going to run this SUMA here. And when you use SUMA, there will be a lot of output text in your terminal, and sometimes it can be useful. It will tell you if you've successfully done some task with a button push, you'll see some message in the terminal, and that could be useful just to keep tabs on what you're doing. So that's just something to note. Okay. For the moment, let's just look at SUMA here. And there's a lot of again, as with the AFNI GUI, there's a lot of key presses and things you can do with a mouse, button pushes and things like this to investigate your data. So the first thing is if you want to look at your brain, you want to look at it from different angles. So to rotate it, you can left click and hold your mouse down and then just move the mouse around. And you can let go and you can rotate anything like that. So that's fine. If you want to rotate with key presses, you can just use the arrow keys. I'm just tapping the right arrow key, left, up, down. You can hold it down and it will smoothly rotate in any of those directions. Okay. And if you want to get a view of the brain in kind of nice classical, kind of full on along the axes, nicely orientated, you can hit Control up and down. We'll show you the axial views. Control, and I'm holding down Control and hitting the left right arrow keys, and I get the sagittal views. And then Control Shift up down gives me the two coronal views, anterior and posterior. Okay, so these are nice ways to get the nice axial views here. Okay. Okay, and again, if I want to rotate the brain, I can. Great. If I want to translate the brain, what I can do is I can hit the Shift key and left and right arrow. Now the brain is translating, or holding the Shift key down, the up and down arrow. Or if I want to use the mouse, I can use the middle scroll wheel as a button and push it down, so the middle button on the mouse, and hold it, and now I can move the mouse left and right and up and down. Okay, so that's translation. And if I want to zoom in and out, so translate kind of closer and further away from the view, I can use my middle scroll wheel, and while my mouse is over the window here, if I scroll, I guess, forward, it'll zoom out, and if I scroll backward, it will zoom in. Similarly, with a key press, I can use just the Z key by itself, so little z and zoom out, and big Z will zoom in. So, Shift Z will zoom in. Okay, so translate, rotate, and shift. So all of that is useful, and that helps me see kind of everywhere around the brain. Something to note is on the surface here, I have these kind of concave and convex parts of the brain here, and I have the medial part of the brain. So how do I really see everywhere in the brain? So let's think about approaching that. Well, I can see everywhere on the lateral parts of the brain. If I want to see the medial parts, one thing I can do is I can turn off one of the surfaces. So we're going to talk about objects in SUMA, and right now it looks like there's just one object, but there's actually two, left hemisphere and right hemisphere. And if I hit the square bracket, either square bracket, so I'm going to hit the left square bracket, that will toggle on and off the left side of the surface. And if you notice here in the terminal, it's telling me hiding left side, fine. So actually I can tell here if I want to know is left equals left or left equals right as I view this by turning on and off the left square bracket, the left hemisphere with the left square bracket. I can tell that left equals right here. And similarly, if I hit either one or both square brackets, I can turn them on and off. Okay, so that can be useful for seeing the medial part of the brain now. I just kind of cleared that one out. If I want to put it back, I put it back. Okay, so the square brackets turn on and off one of the hemispheres. I guess the police are driving by, but they're not after us for using SUMA, so we'll continue. All right, another thing that you might want to do is sometimes when you look at papers, you see that you can see both lateral surfaces or both medial surfaces simultaneously. So there's a fun functionality in SUMA. I've just made my window a little bit wider here. We'll see why. If you hold down the Control key, now left click and hold it down. And now move your mouse left and right. So I just moved it to the left, or I can move it to the right. or I can put it back here in the middle, and now I can move my mouse up and down. So up and down pulls the brain apart, and now while I have control and left click both held down, now I'm opening the brain up. Okay, so this is a really nice way that you can see both the lateral surfaces and both the medial surfaces. Again, I'm holding down control and the left mouse button, and while I do that, now I drag the mouse button around. Okay, so if you've got this far, give yourself a round of applause. Congratulations. And if you put your brain surfaces open like this, you can release them and they stay there. You can zoom out if you want, things like that. If you want to go back to where you were before, to just kind of close the brain fully, you can hit the control key and now double left click. Okay, and that puts it back in the beginning. So again, control left click, and you can open, you can rotate the brain like this, it's fine. Control double left click, and it'll close the brain up again. Okay, something else that we might want to think about for viewing surfaces is that right now, again, we said that there's this kind of concavity and convexity here. It might be a little bit hard to kind of see inside all of these simultaneously, right? If I can see inside here, I can't see what's kind of behind this ridge here. So the sulcal and gyral patterns present a bit of a challenge. But there's a way kind of out of that. If we think of this as being like a balloon, we could think about inflating it, and so the same number of points would kind of stay there, but now all these interior parts would become more flush with the outside, and we might be able to see things more. And something we also have to remember is that what are we actually looking here? So we've said this is a brain surface and we recognize it, but what part of the surface? A real surface has thickness. So this is actually the gray-white boundary. There are other surfaces that are estimated too. What about the outer part, or the peel surface of the gray? So if you hit the period key or the full stop, now actually this is the peel surface. So this is kind of the outer gray matter surface, if you will, and we were just looking at the inner one. So this information was also estimated by FreeSurfer. I'm going to hit the period key again, and there's actually a series of surfaces, and they all have the same number of nodes, and we'll talk about this a bit more. But these are different ways of representing the same surface mesh. So this one is quite useful because it has this inflated aspect, and there's nothing hiding in sulci and gyral patterns here. I can see everything at once. So this is a common way that people present data. And if you wanted to show both lateral surfaces there you go. Control Shift up, there you go. So that might be a nice way to look at your data. Or if you wanted to show both of those surfaces, you can move them apart a little bit. There you go. Okay, so again, we're just toggling through some of these different brain views here with the period key. These are actually, you can imagine if you really fully inflated as a balloon, this is the left and right hemisphere. These are actually useful when we use alignment, and we'll talk about that a little bit later. That's they actually have a purpose rather than just being some kind of globe view of the brain. And we're back. So the period key will toggle you through this list of surfaces, and you can actually see here in the terminal what surface you're looking at if you're ever wondering. And the comma key will move you through that list in the reverse direction. Okay, so here we are back at our standard white viewing here. Okay, so the gray-white boundary. All right, so now we know how we can see lots of data here. Okay, now let's take a little bit more of an investigation at what our mesh is here. It really looks smooth, but if you notice here, there's this kind of jaggedness to this coloration here. Well, what's happening there? Why is that? What are we looking at? We might think that this is a nice continuous and smooth object, but a computer, really nothing is. So what happens now if I right-click somewhere on this surface? Okay, now we see a couple things happen. There's text that appears up here, and there's something that appeared here. So to zoom in, you can use Shift-Z or just the scroll wheel. Once you get into using SUMA, it's really nice to have a scroll wheel handy. First things first, let's actually look at here at this text. This text says white matter, left hemisphere, G, front sup. So frontal superior gyrus. And if I click anywhere around here on this brain, you'll see this text changing. White matter, left hemisphere, superior, sulcus, precentral, inferior. Okay, and you can click anywhere. Again, FreeSurfer has parcellated the cortex for us. So that's what these labels are. So these labels have stuck through and they exist on the SUMA surface now. This convexity here, if we notice, if I click down here, the convexity has a negative value. If I click up here, convexity has a positive value. And actually the coloration of the surface, which we can look at how to adjust later, is representing convexity. And this is a property that FreeSurfer has estimated. So basically it kind of tells you if you're in a sulcus or gyrus, whether you have positive or negative convexity. Okay, now let's zoom in here, what's happening. Now this is a funny little shape thing here. There's this yellow ball and then this kind of grid of stuff, these sticks coming out of it. What is that? Well, this yellow ball, if I right click, again, in AFNI you left click to move around crosshairs. This object here, the yellow ball with the red, blue, and green sticks coming out of it, is actually our SUMA crosshairs. And as I right click and drag or just right click around, it moves. These sticks tell me what my left-right direction is, anterior, posterior, and inferior, superior. So left-right is along the red axis here. Anterior, posterior is along green. So this would be like sticking out of the screen if I look at it kind of straight on. And blue is inferior, superior. Okay. Now, what is this triangle and what is this other purple dot that's kind of following at a safe distance, it seems? Well, let's zoom out here. This thing that we think of as continuous, it's actually a mesh. And if I want to show you what a mesh actually is made of, I'm going to hit the P key. All right. So now if you notice here, I see that this is what I mean by being a mesh. And if I hit the P key again, what do I see? I see the nodes of the mesh. It's actually quite pretty. If I hit P, it's gone, and once more it comes back. So hitting the P key will toggle me through this, will push me through and sequence this list of seeing the edges of the mesh that connect nodes. So if you notice, everything looks like a triangle here. These dots are the nodes themselves. And what I'm actually looking at here is each triangle from the edges that is colored in with the surface and information. And if I zoom in here now what this triangle is, so see this triangle and I'm going to hit the P key, you'll see that this triangle that's highlighted is just showing me the triangle within which I happen to click. And this purple dot, if I move around, you can see it's actually the node that's closest to wherever I'm clicking. Okay, so that's what these pieces of information are actually telling me. So here you can see I can kind of click at a place where this, it's kind of obvious that it's triangular. Again, now this is the surface area within which I've clicked, and then the purple node is the node closest on the mesh, closest to where I've clicked. And it's actually at this node where this information and all information that I'm getting takes place. In AFNI, on a volume, what holds my data? A voxel does. In SUMA land, on a surface mesh here, what holds the data? A node does. And so it's nodes that store one or more pieces of information. In this case, it carries a label and a convexity value that I'm looking at. Okay, and then in AFNI land, when we think about a voxel having neighbors, we can talk about NN equals 1, 2, 3, or sharing faces, edges, or nodes, or some form like that. What defines a neighborhood or a neighbor in SUMA? Well, the direct neighbors of this node are all the other nodes that share an edge. And then sometimes we can also think about, well, let's say if I could draw a radius out on the surface and then keep that, find all the nodes within that radius, something like that. So those are the ways I would define a neighborhood, by direct edge connections or through some kind of all the nodes within a radius constrained to the surface. Okay, so those are the pieces of information there. If I don't want to see the crosshairs, in AFNI you can turn it off. You can turn off crosshairs here as well. In this view button here, you can turn on and off seeing the crosshair, the node in focus, which is that purple dot, and the selected face set, which is that white triangle. So if I select this, let me zoom in before doing this just so it's clearer. Okay, so I've zoomed in. If I select here and select that, you see that the face set is gone. If you notice, there's also, it tells me the key presses with F3, 4, 5 to turn these things on and off. So if I hit F3 now, I have to hit the function key on my computer. There, I hit F3 and I'm turning the crosshairs on and off. F4 and I'm turning the closest node on and off. And F5 there. Okay. Something else to note if you're using like a desktop or something, if you have the numlock key on, a lot of this functionality will behave kind of oddly. So you should really not have the numlock key on when you're using SUMA in particular, and also in general with AFNI. Okay, let's think about what other functionality I might have forgotten. I'm going to go over here to this cheat sheet, which actually has a lot of these things on here. So right click node selection, right click drag, we've talked about, I can just do that. Left click control and left drag is this prying the hemispheres apart, what we call the walnut brain, because it's like opening up a walnut. Let's see, prying them apart, that's fine. Okay, right. Let's talk about opening the help. One thing to note is, as I do these key presses, if I have my mouse over here, and let's say I type Control H now, I'm surprised it actually worked. For most key presses, your mouse has to be over the window here. So now what we have is a help menu that's searchable. So let's say I forgot how to do something. Let's say I wanted to know how to rotate the brain. So I can go in the search pattern and say, rotate. Okay, and I can just hit enter. And now in this giant help file here, it will find instances of the string I searched for. So the left-right arrows rotate about the axis and things like this, and fine, now I can actually do that. So, and if I want to keep searching, I just hit enter again, and it will find the next instances in here. So it's nice to have a searchable help menu for SUMA here. And again, to note, that's Control H. Something else that's useful to know about where to find out things about SUMA is here on the AFNI documentation. There's a whole SUMA section. And there's a lot of what we talk about, again, just like with the AFNI GUI, there's so many button presses, key presses, and mouse clicks and things like that. So a lot of it is displayed here. So if I go to the SUMA viewer, again, this is kind of just what we've done here. There are different ways to look at the data and key presses and different things to remind yourself. And something else I'll note, that while I'm here in the help pages, under tutorials and examples, there is one with using FreeSurfer. This example right now, it's 10.13, but under tutorials and examples, there's one using FreeSurfer. And this is just a basic usage of FreeSurfer with recon all. So at its most simple, you have an anatomical volume, your input, and then you run recon all on it. When that is done, and it takes a long time, as everyone is well aware, it can take up to a day sometimes, but just many, many hours. And then when that's done, you can run @SUMA makespec fs to bring all the output into kind of usable or more generalized NIFTI and GIFTI surfaces. So here's an example. And there's some comments on file paths and also some of the data sets that we make for convenience we mention here. So these kind of renumbered ones and the ones that are labeled, they have these ren for renumbered. And so they're described here. And there are some convenient data sets either for the tracking or for using in AFNI proc sometimes. Okay, so again, there's this tutorial on using FreeSurfer and ReconAll. Okay, so here's one help menu, and we've just seen also that on the web page there's the SUMA help page as well. So both good places to get help. Okay. All right. We've used the arrow keys for rotations. This is good. The home key, actually, if you do something weird and your SUMA is kind of open and I don't know somewhere, and you just want to kind of reset things, the home key will reset things. Okay. And we've talked about some of these. All right, let's talk about the motion. One thing that you can do, let's see, Control-Shift up there. Okay, so I hit Control-Shift up to just get that coronal view. One thing you can do is I can rotate the volume like this, but it stops as soon as I'm done. If I want to, I can turn on a motion mode. So now while the mouse is over here, I'm going to hit the M key, M as in Mike. Okay, so nothing's happened ostensibly. But now if I just press one arrow key, and watch what happens. So I'm not holding the arrow key down, you'll have to trust me, and the brain is moving. If I just click on, it'll stop. If I left click and hold down and move my mouse and let it go while I'm rotating, or while I'm moving the mouse, you can kind of flick the brain, give it some momentum. So I left click, hold, and I move the mouse, and while the mouse is still moving, I let it go. And this has basically momentum. If I do this quickly, I can spin the brain faster. Okay, so this is a way that you can make a movie. Sometimes people have for demos and things like that. And we'll talk about recording in a second here. Okay, and while it's moving, you can kind of reset it and things like that with the arrow keys and Control-Shift and all that. So now it's moving slowly. If I want it to stop, I can hit the M key again, and now the momentum mode is off. If I hit an arrow key just once, it doesn't keep that momentum anymore. Okay, so the M key toggles this motion on and off. Okay, let's talk about saving images and recording things as well. So up here, if you go File, kind of Save View, you might think that that's going to save a picture of what we're looking at here. Perfectly reasonable thing to think, but that's not actually the case. What that does is the view actually refers to, have I rotated the brain, have I translated it, things like that. And I can load up the surface with the same kind of offset properties as before, so I don't have to always do the same sets of button presses. If I want to record an image of this, I can type Control R. Okay, and now what's happened here is that there's text in the terminal here that tells me that it wrote an image in this file and this kind of ugly name. This ugly name is actually useful because this is a timestamp. So this stands for 2007, 2020, 7th month, 23rd day, this time. Okay, and by default, it puts it into a directory from where I launched SUMA called SUMA recordings. So if this didn't exist, it would get made and then start populating with images. And every time I hit Control R, just to prove the point here, I'll get a new image, and you can see the timestamp is updating. And so now I have, if I type ls, you see there's a directory SUMA recordings, and there's all these images that are getting populated there. Okay, so those are JPEGs, and if I open them, I'm just going to use EOG here. I had some images in there from previous recordings here. Okay, so these are just the images I recorded now. If you notice, the text is here. If you want to turn the text off before you make your image, then I think that might, let's see, it's one of the F keys. I could search for it. Let's see here. I'm pretty sure it's F. Let's see. I'm just investigating key presses here. Oops. Well, while I'm doing this, this is the F2 key. You can turn on a separate grid with units and things like this. If you keep hitting F2, you move through this list of different styles of grid patterns, and this can be nice to show the directionality in there. There, it was F9 all along. I thought I hit F9, but there, this turns the text on and off if you want. So hiding the label. Okay. And let me turn off this. Okay, so this was F2. There we go. Something else to note, when you save images in SUMA, the way that you control the resolution effectively is, let's say you're always going to make an image for a journal paper that is going to end up being 3.5 millimeters wide. The way you would effectively get a higher resolution image is by making your SUMA window here as large as you can, and then taking your image, so Control R. And now in this image here, what you would do is you take it and then it'll be basically the same size as when you took it, and so by compressing the size down here, it becomes effectively higher resolution. This is because the SUMA image recording, the Control R functionality, is basically kind of doing a screenshot, and so the resolution that you're looking at is kind of what you see is what you get. And so if you have a nice large screen, you can make the window big, and then it'll effectively be higher DPI when you get it to the actual size that you want. So just a way to know how to control the spatial resolution there. Okay, so those are just images. If you remember on the AFNI videos, you can record videos. Same thing can happen here if you type Shift R. Now it tells you in the terminal recording is on. Doesn't look like anything has happened here, but if I now left click and drag, if you notice, this kind of avatar thing jumped up here, and if I get my previous window, my SUMA window is still around here somewhere. And I've lost it. There it was. Okay. So here's my SUMA window. This thing here is actually just an avatar, and it works a little similar to the AFNI recorder. So if you watch this number here and see what happens, as I do something here, you'll see that the brain rotate. This is just kind of following me, and this number is getting bigger. Essentially, every time I change the SUMA viewer and how it looks, there's a new snapshot made and kind of added to the list. They'll get concatenated and turned into a movie. If you notice here, while I'm just kind of talking, this number is not getting bigger. This would not be a long pause in the video. It only records successive changes at kind of constant rate. Okay, so let's say if I'm done here with that, now nothing has been saved yet. This works very similar to the AFNI case. There's a save button here. If I just look at it, I notice actually in very tiny font it says .jpeg, so it's not actually about to save a movie format, which would be different. So I'm going to right click on it, and down at the bottom here, depending on how your computer is set up and your dependencies, you might have one or both of GIF and MPEG formats here. I'm just going to select MPEG for the moment. Okay, and I hit set. I still have not saved my actual video yet. I've just chosen the format. I'm going to left click on this button, and now I'm going to just type something movie. And again, similar to the AFNI video recording here, I can go from the 0th image to 190, this maximum, or I could take a subset. I could chop off the first 10 there. I could chop off the kind of first 10 images of this. I can watch back in time and see what those were. Maybe I wasn't happy with those, and so now I could just start at the 10th one. So now my video recording would start here and go to the end, or I could chop it off, but then I'm just going to hit set. And if you see here now, I see that it's actually saving. And if I kept my terminal here, yes, it's actually told me the terminal how it's saving it. And if I type ls-ltr to see a time reverse list, there is my movie. And let's see if I recall. Nope, I think it's VLC movie. Okay, so there's it. If you notice, there's no long pause from when I paused. It just plays it there. Okay, so now there, I've saved my movie. I can close this and life goes on, and here I am, and let me just rotate my, oh, what do I notice? Well, my movie recording is still going. It's now started over. I didn't turn off that recording setting, that environment. So now every time I do something here, it's going to start this recording thing again. So what I want to do is hit Shift R and turn recording mode off, and now I can see in the terminal it actually told me, yes, recording is off. Okay. Okay, so that's how you record videos. So Control R will take a snapshot of an image, JPEG, and Shift R will turn on the recording. And sometimes one thing you might want to do, for example, is let's see, you could start recording with Shift R, and now I could hit the M key to turn on motion, and then just hit the arrow key gently, and it's going to make this rotating brain here like this. Cool. Now, this is going to keep rotating. If I get up and make a cup of coffee, it's going to go, and this is just going to get bigger and bigger, and eventually it might use up all the memory on my computer and kind of crash it. So don't turn on the momentum mode and walk away. Okay, so I'm going to stop. Let's see, Shift R to stop the recording. And if I wanted to save this, I could. I don't particularly care to, but there. Okay, so you can turn on the momentum mode and make one of those nice kind of rotating brain presentations if you want. That can be a nice thing for closing or ending a conference or something. Okay, let's see, what else do we have? We've gone between the states with the comma and the period. Points, lines, triangles with P. All right, let's see. The surface object controller, we haven't looked at that yet. Let's do that. So if I go here to view, there's this object controller here, or I could type Control S. For the moment, I'll just go View, Object Controller, and this opens up the equivalent of kind of my AFNI GUI controller for SUMA is this thing here. And similarly to AFNI, it has some features. It tells me where my crosshair is, the location. So this is in XYZ coordinates. And so let's see if I have space to do this. There we go. So now as I move this around, you see these numbers of the crosshair changing. It tells me my node number, every node in this mesh, if I hit the P key, every one of these nodes is labeled with an integer, 0 to 200,000, something like that. And as I move around my mesh, I can see the label for each one. Everywhere I click is defined to be in a particular triangle. So here, every triangle has a number, and every triangle is made up of 3 nodes. So these are the node indices. You can see the one that I've selected is one of these. This is the XYZ location of the node, not just my crosshair, but the node on the mesh. And we can see the coloration. Here's the label. Okay, so this is telling me about where my crosshair is. If I hit the P key again a couple times, P. Now we see here that this data set here is meaningful. It's the convexity, so it has a label convexity. It's the smooth white matter that we're looking at here. Smooth boundary between gray and white matter. Something I can do is I can change the color bar, or in SUMA is referred to as color map. And here is where I can do it. So right now the current color map is gray 02, a 2-tone gray. If I left click on this menu, I just see a phenomenally long thing to select from here. If you remember from the AFNI GUI, there's a trick whenever there's one of these menus that's so long. If you right click on it, you will get a scrollable menu. So here's the gray 02, gray 20 looks a lot more continuous, right? That's a 20 color bars instead of 20 grays instead of grayscale of 20 instead of 2. If you want to, of course, then there's colors. You can have an alien brain that looks kind of like a rose, I guess. Any color bar that's meaningful and useful. This one, maybe not so much here, but okay. I kind of like the gray 20. All right, so again, this CMP is color map. Now, as we navigate around this GUI, it's very easy to kind of get lost or not understand what these abbreviations are everywhere. If I go somewhere and hover over a label, this again, sorry, while the controller is in the foreground, if I hover over a label, I should get hovering. Okay, well, if you go to B help and click on one of these labels, you'll get the button help of it. So this help is tells you about what's happening there, and we call it button help because this is a button. So if you click it, it will go away. I'm not exactly sure why the hovering, if I hover over one of these, it should tell me a very brief help, and I don't know why that's actually not happening. The W help here, this gray hard to read button, if I click on that and now go somewhere and click on something, let's say I'll click on this I, that stands for web help, and it will bring me here on the online documentation to something labeled with that. So the I that I selected is the intensity column or the sub-brick. So this actually determines how the number that gets mapped to this grayscale color, that's the intensity, and it's in this convexity volume here. Okay, so W help, I click on this, and now I can click on things and get brought to the web help online, which is pretty handy. You do have to be connected online for that to work. Okay, and we'll talk about objects later when we have more of them. Okay, I think this is the main part of the SUMA controller that I wanted to go over. Let's see, what else do we have here? I can open up with Control N an additional viewer. So if I'm here and I type Control N, now I have another view, and actually they're locked together. If I left click and drag, and if I take this one and hit the period key, this can be useful to have two different views. Let's say here, now I have two views of the same thing if I want. Okay, but I'm going to close that now. I think that's most of the functionality here, except for one really fun one. I've had AFNI here open for a while now, not really doing anything. And why did I do that in the first place? Well, we've mentioned that SUMA and AFNI are complementary. One way that they're complementary is that the GUIs can be open and send information back and forth to each other in kind of real time. So the way to turn that functionality on, you have to be a little bit careful here. So these communicate through ports on your computer, and sometimes if you kind of keep turning the communication on and off, it will confuse things and they'll just kind of give up. Another thing to note that I should have mentioned before all this is that by default, if you don't specify the communication channel for them, you should only have one AFNI and one SUMA open to make them communicate with each other, but we'll talk about that in a second. So while I have the SUMA panel and the mouse over the SUMA panel here in the foreground, I'm going to hit the T key. And T stands for talk. And if you notice what's happening here in the AFNI control panel, there is now these lines that have appeared, and what these lines are the surfaces from SUMA, and not just the one that I'm looking at here, but actually the family of lines. So the inner and outer gray matter, if you will, the gray-white boundary and the peel surface, left and right hemisphere. And I see it in all of these. And if you notice here in the controller, there's a button that has just become highlighted called Control Surface. So let me click on that. And this allows me to control how I'm viewing these surfaces that are sent from SUMA into AFNI. One thing I can do is I can turn some of them on and off. There are 6 of them. There's the standard mesh left hemisphere smooth white matter, the right hemisphere smooth white matter, left hemisphere peel, left hemisphere white, right hemisphere peel, right hemisphere white. These show you the colors for all of them. If I wanted to turn some off, I could just deselect them. Okay, so you see them kind of disappearing and reappearing. If I wanted to change the color of one, let's see, this yellow is this left hemisphere peel. If I wanted to make that orange-red, now I have. If I want to make it this eggplant color, now I've done that. If I want to make these lines a little thicker so that they're more easily viewed, I can go up here to line width and make it, let's say, 2. That might be a bit much. Let me just make it 1. No, 2 is better. And if you notice here, as I adjust, there's a couple. What is this green line? It's kind of hidden by this eggplant one. There's left hemisphere smooth and left hemisphere peel. So let me turn this one on. Oops, sorry, the pink line here, hot pink. There. So there's actually 2 things here that are almost the same line, just not quite. You can see a little bit of green peeking through. The gray-white boundary and this smooth gray-white boundary are almost the exact same line. So sometimes I'll just kind of turn off one of them, and here you go. Now, this is useful functionality 1, because it's kind of pretty. A second one is, how do you know that FreeSurfer or any of your surface generating tools did a good job? You need to be able to look at it, and you need to be able to look at it and compare it to the data set that you put in. So this is a way that you can kind of walk through the brain and check and see if these lines seem reasonable. Is your inner and outer gray matter surface well represented? Are there knots? Are there weird things? Here it looks pretty good. If I walk around here, I think it looks pretty good. There's a little bit, it got outside the gray matter here. Yeah, here there's a little bit of a problem, but this kind of thing. So you have to decide what's good enough, etc. But the nice thing is that you can do this and you can look at your data in vivo like this. Okay, all this functionality here. Oh, and let's say also I should notice here in SUMA, the connection is still live. If I right-click somewhere in SUMA, I update my location in AFNI. Okay, so there's lots of ways that SUMA is sending information to AFNI. Where's the crosshair? Where are the surfaces? AFNI can actually talk back to SUMA, and the best way to see that, let me close that, is to put an overlay now in AFNI. Overlay, and what should I overlay? Let me overlay gray matter ROI data set here. This is kind of a big data set. Okay, so letting AFNI finish loading it. Well, here you can see AFNI has opened up this this data set. Okay, so it's overlaying just as we'd expect, and if I right left click somewhere in AFNI to update the crosshair location, there's a little bit of lag now as the computer is catching up with me. Hopefully, okay. So now here, if you notice here, the same labels that we expect in AFNI are kind of there, so fine. The labels from FreeSurfer are still around. What's happened in SUMA? Well, all the colors from my overlay are being sent to SUMA. So it's not sending numbers, it's really sending the colors of where the surface is intersecting the overlay data set. So if you see here, there's a little bit of just like, sometimes little bitty pieces will be left off from this because I only have something that's kind of right on the surface. But you can see that the colors are still there. I'm not actually sure if I'm looking at the same, I should have been careful that I'm looking at the same parcellation data set here to see, so I could check if the ROIs match. They should. Yeah, so I think I did happen to fortunately overlay the same of the two parcellations. So the AFNI label is the same as the SUMA label. This is actually the label on the surface data set, not of the colors here. But anyway, these are really there. Now, if I take AFNI and let's say I threshold this, this isn't really a data set that I would tend to threshold in the same way, but let's just say I do it for the example of thresholding. So now here in AFNI, you notice some of the ROIs are no longer shown because they're basically thresholded. SUMA updates as well. Okay, so the ROIs that had an index label below 93 or below here are no longer shown here. Okay, so this is pretty nice, and if you want, this is the way that allows you to, if you want to display your volumetric results on the surface using one of these standard meshes, for example, you can do it. So now here, maybe if I want to present this more, I'd hit the period a couple times, and now I have this pretty nice representation. And if I control shift, let's see, do this. There I have that nice view, or I can close the brain and have that nice view. If I had a statistical data set or something like that, it'd probably look a little bit more normal. Okay, so these are a lot of the basic AFNI and SUMA functionalities and driving, and all the key presses that we did are here still, and we'll take a break and continue with some more discussion later.